Welcome everyone. This lesson will be looking at the properties of quadratics. We'll be going from converting from one form or to another, as well as we'll be looking at some application type questions. So let's get started. So for example 1, express each quadratic function in standard form, state the y-intercept of each. So just remembering what standard form looks like, it's ax squared add bx add c. So as you can see, this has no brackets. So we want to take this factored form and we want to rewrite it in standard form. So the first thing we will do is we're going to just do our distributive property here and multiply through using, you might have used the acronym FOIL, but we're just multiplying each term in the first bracket with each term in the second bracket. Then we just need to simplify this by removing the bracket, and also we're going to collect the like terms here at the same time within the bracket. So once again, if we distribute the negative, this will be a negative x squared, a negative 6 and a positive 4, that would be negative 2, but we have a negative outside of the bracket for a positive 2x, and a negative would be a positive 24. We know in standard form, the c value is the y-intercept. So here the y-intercept is 0 and 24. Let's try an example where it is in vertex form. So this was in factored form. And we have an example here, this one's in vertex form. So we're going to do the same thing. We're just going to rewrite, removing the brackets and expanding. So we know this is a perfect square trinomial. Sorry, this should be a negative here. Add 18. And then we can distribute our 2 into the bracket. And then lastly, collect the like terms. Once again, we will get our y-intercept from this last term, or the c value. So the y-intercept here is 0 and 26. So if you're looking for the y-intercept, you really just need to change to standard form in order to get your c value. Example 2, find the vertex given the equation in factored form. So we know from the symmetry of a parabola, let's just create a little sketch here. We know our zeros here would be somewhere over here at -4 and a 0 over here at 6. We also know that this opens down. So let's just state we know our zeros are at -4 and 6, and this opens down because of this right here. So if I just do a little sketch, I know, it's going to look something like this. Due to symmetry, we know that the h value, remember this is a vertex, which would be our h and our k right here, would be halfway between these two zeros. So our first goal, if we want to find the vertex, we are going to first find that h value, or the axis of symmetry between these 2 points, and that will give us the h value. So that will be our first step. So let's first find the h value. And we do that by adding our 2 zeros together and dividing by 2. So in this case, when we add these together, we'll have 2 divided by 2. So we find that x is equal to 1, or that the h value here would be 1. Now we have to find the k value if we want to find the vertex. In order to find the k value, we just need to take the original equation, so find k value. We'll take the original equation, and we're going to substitute in our x value. So we'll take this value and we're just going to substitute it into this equation. If we simplify this, we get that the value here is 25. So we know this represents the K value and this represents our H value. So then we can say the vertex is 1 and 25. Our next example is more of an application type question. You'll see that you'll have to do a couple of these in the homework. So it's just basically understanding words in this one and how the words relate to our equation in order to solve this. So let's start. We have the flight of the firework is modeled by the relation h is equal to -5, t minus 5 squared add 25. So you should just have a little visual. So we have a firework. It has been launched. It just goes up and then it comes back down. It's going to come up to a maximum point here. Our vertex, which we know our vertex here is at 127 and 5. This would be our height, this would be our time, just to have a little visual of what is going on here. So this is the vertex and it's given right here with our height of 127 and the time would be at 5. Where h is the height in meters, the fireworks above the ground, and t is the time in seconds since the firework was fired. So we know this would represent our time 0 here. What is the maximum height? So we're looking for maximum height. This should trigger right away that you need your vertex, right? When we see the word maximum reached by the fireworks. So once again, this is our vertex. We know it reaches the maximum height of 127 meters. I'm not writing out the statements. I mean, on an evaluation, you want to write it out, but just due to the length of the video, I'm just going to be writing the answers in here. How many seconds after it was fired does the firework reach this height? So when does it reach its maximum height? We want to know how many seconds. So that comes from here, right? This is at 5 seconds. So that would be 5 seconds. How high was the firecracker above the ground? So how high, that means we're going to look for H. We want to know what H is. Was the fireworker above the ground when it was fired? So when it was fired, we need to know what this value is, because if we have an equation that has two unknowns, an H and a T, if we want to solve for H, we have to substitute a value in for T. When it was fired, the time was 0, because this is when it's fired at time 0. So we're just going to write down our equation. And we'll substitute in our value of t equal to 0 right here into our equation. And then we'll just simplify that using our BEDMAS rules. Sorry, running out of room there. H is equal to -125 at 127. So we get the height is 2 meters. So right here, we know it was at 2 meters above the ground when the firework was launched. When, if we're looking for when, this time we're looking for our time, right? Whoops, sorry, not 0, but time is a question mark here. Hit the ground. Hit the ground. That means we need to substitute in a value for H. What is the height here when it hits the ground? We know the height here is equal to, equal to 0. So we know the height is equal to 0 when it hits the ground. So let's start with our equation. H equals -5, t minus 5 squared at 127. And we're going to substitute in 0 for our H. Now we're just going to have to solve this for t. So to solve this for t, we're first going to move our 127 to the opposite side. Then we're going to divide both sides by our -5. Then we'll have to take the square root of both sides. And then we'll have add 5 is equal to t. Now we can just put this in our calculator and calculate those values out. Hopefully you can do that on your own. So I'm just going to write down the answer here is 10.0 seconds. Okay, so just put this into your calculator and calculate out that value. Our next example is looking at how do we write, we did a bit of this in a previous video, but how do we write the equation given the graph? So it doesn't really state what form of the equation we have here. So we're just going to look at, you know, which form makes more sense given the information that we can read from the graph. So our first one, since I can see where the vertex is, I'm going to write this equation in vertex form. So if I want to write it in vertex form, then I'm starting with this equation, and I need to find values for A, H, and K. We can see right here is our vertex is 1 and 2. So we have our H and K value. We could maybe read this from the graph because if we go over 1, it looks like we go down 1/2. If we go over 1, it looks like down 1 1/2. So I would assume that this looks like the A value is -1/2, but I'm just going to actually show you how you could calculate that. So we can see that the steps look like we're going in this form, but let's calculate it as well. So if I can't read what the A value is here, I need to find a value for my X and my Y. So that just means finding another point on your graph that you can substitute in for an X and Y value. So there's a few different values that we could pick on this graph. I'm just going to go over here because I haven't written as much over here. And I notice that I have this point on the graph of 3 and 0. And this gives me an X and a Y value. So I'm going to be using my vertex of 1 and 2, and I'm going to be using the point of 3 and 0, and that is to calculate my A value. So let's substitute those in. My Y value is 0. I'm looking to solve for A. X is 3, my H is 1, and the K value here is 2. If we solve this, using our BEDMAS skills, we'll bring the 2 over, and then we'll divide by 4. We can see when we calculate the A value that it is actually a -1/2. So now we can write our equation. So we know it's -1/2 X subtract 1 squared add 2. So that is writing it in vertex form. When I come to this graph, though, I can't really read the vertex. It's a little bit difficult to read, but I do notice that I can identify here my X-intercepts or my zeros. So it would make more sense to first write this equation in factored form. So this time we're going to start with factored form, which looks like this for our general equation. So first off, in factored form, we need our zeros. So the zeros from our graph are at -1 and over here at 0.5. Once again, we can't really read the A value here, so we're going to have to solve for that. So that means we need another point that we can identify on the graph. So I'm going to go up. I can identify this point right here at 1 and 2. So I'm going to use the point as well, 1 and 2, and this gives me an X and a Y value that I can substitute in. So my Y value here is 2, is equal to A. The X value is 1. My first 0 is a -1, but remember when I put it in, that'll make that a +1. Once again, my X value is 1. My other 0 is 0.5. So let's just simplify our brackets. We have 2 and we have 0.5. And then we know half of 2 will just be 1. And we get an A value for this one of 2. So then we can write our equation in our factored form. So we have X add 1 and X subtract 0.5. Our last example is taking given information and being able to write the equation. So taking these words and understanding what they mean in terms of our variables or parameters in our equation. So first, axis is symmetry at x equals -2. I know the axis of symmetry is also the value of my h value. So I know here from this information that h is -2. A minimum value of -10. This tells me my k value is equal to -10. Then I have a 0. But I can already see from my h and my k value here that I'm probably going to want to write this in the form of vertex. So I have an h and I have a k value. So I'm going to need the a value once again in order to write this. So when I see that there's a 0 at x equals -3, that tells me I have a point that I can use -3 and 0. So this will give me my x and this will give me the y value, and I'm just going to substitute those into the equation. So I have 0 is equal a, my x value is -3, my h value is -2, but that will make it a positive when we put that into the bracket. And then we have -10. Simplifying that, once again, just follow your BEDMAS rules to simplify. We'll bring our 10 to the other side, and we'll make that positive. -1 squared is just 1. So we get an a value of 10. So then we can write our equation. F at x is equal a. X, our h value, remember, was -2, so that'll show up as a +2 inside the bracket, and that is our equation for that quadratic function with those characteristics.